In this video, we're looking at section 9.2 topic of writing solutions to 3x3 systems of linear equations from augmented matrices. Determine the solution set for the system represented by the augmented matrix. So we have, in the first row, 1, 0, -3 on the left side and 7 on the right side. What does that mean? Let's go ahead and translate these into equations, okay? The very first column gives us the coefficients for x. So when they have this number 1 in the first position, in the first column, then what we have is 1x. So we have 1x. The middle column gives us the coefficients for y's. As you can see, we don't have any y's on the first row. So 0y, I don't have to write that. Now the third column gives us the coefficients for z's, and we have -3 in the first row. So we will say that is negative or minus 3z. And to go to the other side, we will put an equal sign, and let's put 7 on the other side. So that's what the first row is representing. We have 1x minus 3z equals 7 from the first row. Let's go look at the second row. The second row has 0, 1, 5, -5. So when we have 0 in the first position, that means 0x. So I don't have to write any x. But notice we have 1 for the y. So I will say 1y. And for under z, I do have 5. That's +5. So do write plus 5z. And all that equals what number on the other side? -5. So we'll write -5 here. So we translated the first row and the second row into equations. Now let's look at the third row here. Third row is super interesting. Look, we got 0, 0, 0. So no x, no y, no z, nothing. And they're telling us that equals 0. Well, though, that's so true, right? This third row is telling us basically this. 0 equals 0. That's a true statement right there. So this is your hint. Whenever one of the row is telling you 0 equals 0, because you have 0 everywhere, okay, 0, 0, 0, and 0, this last line tells us that this system has infinitely many solutions. We're not done though. We're going to have to give them a general solution set, okay? So what I will use is these two red and orange equations. So copy that down. I'm gonna go ahead and write these down here. And I will use these to write a general solution set for them, okay? It can be, there are infinitely many solutions, but we're not saying anything can be an answer, okay? So let's take a look. First of all, notice that I have 1x and 1y. Let me erase these ones in front of x and y because it's just x and y, okay? Now watch this for me. What if I move this -3z to the right-hand side? I'm going to move that -3z to the right-hand side. Then the new equation will look like this. I will have x equals 7. And when I move that -3z, that's going to turn into a plus 3z because I'm adding 3z to both sides to move it. So what I can say is x is equal to 7 plus 3 times z. Okay? I will do the same thing for this orange equation. I used to have y plus 5z equals -5. But if I move this plus 5z to the other side, here's a new equation. I'm going to get y equals what? -5 minus 5z. So here is, we can write the final answer now, okay? X has to be, look what x has to be. X has to be 7 plus 3z. I'm going to say 7 plus 3z for x, comma. Now, what does y need to be? Y needs to be -5 minus 5z. -5 minus 5z, comma. And now, what about z? Well, z can be anything they like. So we're just going to tell them z for z. So what's happening is, if they pick any z, then in order to find the corresponding x and y value, they will need to just follow these rules that we give them. So they can pick a z of 0. Let's try that, okay? What if they pick z equals 0, okay? If somebody picks, I want to use 0 for the z value, then x will be 7 plus 3 times z, or 0, and the y will be negative 5 times minus 5 times 0. So if you simplify that, you will get 7 for the x value, negative 5 for the y value, and 0 for the z value. So this, well, it's like a formula, right? This general solution tells I guess our readers, okay, whoever's using the system, that they can choose any z they want, but depending on what that z is, they will be able to find the corresponding x, y values just by plugging in the z into these expressions. So this will be what I circled in gray. That will be the general solution. Okay, that will be the general solution. Even though we have infinitely many solutions, that doesn't mean all real numbers. There are infinitely many answers out there, and in order to be a solution to the system, it needs to fit in this, okay? And if you ever need to give a example of a solution, this is one of the solutions. Well, I don't want to say one solution, but this is a solution. This is one solution, okay? But we can get infinitely many, a solution. This is one solution right there, okay? But we can come up with many more solutions like that by using the formulas that we came up with. So it's easy if you stop at infinitely many solutions, but using the other lines, we should be able to come up with the general solution where the answer only uses one variable and the other ones depends on that one variable, okay?